Alright, welcome to this part of the question 5. We are still getting back to the first story sheet that we're working on under ring chemistry and functional group. So we want to look at question 5. And the part for question 5, we've been given different kind of questions. We've been given A, we've been given B, C, D, E up to H. So we want to practice these questions. We want to predict the major products that are going to come out of these chemical reactions after reacting them at different conditions or in the presence of different reactions. So the first question that has been given here is there's an alcohol here, and this type of an alcohol is a secondary alcohol, and this is being reacted in the presence of PCC. So reacting this reactant here, so in the presence of PCC, what are we going to get? So one thing that we must understand here is that PCC is a weak oxidizing agent. It is an oxidizing agent. And you also look at the product that was being, the reactant that has been given here. In the reactant, for having a secondary alcohol. That's one thing that we must note here. We're having a secondary alcohol. So this secondary alcohol that has been given here has got what? It has got the OCH3. So in the presence of a weak oxidizing agent, and this weak oxidizing agent is what we're calling PCC. So this is a weak oxidizing agent. A weak oxidizing agent. But it is an oxidizing agent. Right. So this secondary alcohol will be worked on by PCC, which is a weak oxidizing agent, to give us what? So what do we call, or what are the end products after oxidizing the secondary alcohol by a weak oxidizing agent such as PCC? We're going to get what we're calling a ketone. So our end product is going to be this. We're going to have a ketone there, and then the rest of the question will proceed, of the structure will proceed. We've got OCH3 attached at that point. So one thing I'm trying to point out here is this. The alcohols are able to react at different conditions. They're able to react in the presence of PCC, they're able to react in the presence of the joins reagent, and they're able to react in different conditions. And I'll point out one thing here. One thing I'll point out is this. If you're having an alcohol, okay? You're having an alcohol. This alcohol, you have it here. This alcohol can be taken into a ketone or an aldehyde through a process, okay? And that process is what we're calling oxidation. So you can oxidize the alcohol to a ketone or an aldehyde. And these different oxidizing agents are like a bunch of them. They're different. We've got PCC, which is a weak oxidizing agent. We've got the joins reagent, which are strong oxidizing agents that can be used to convert the secondary alcohols or the primary alcohols to the aldehydes or the ketones. Like what we're having here, this is a secondary alcohol, and it's telling us something. Since this is a secondary alcohol, in the presence of PCC, we're going to get a ketone. But if this was a primary alcohol, in the presence of PCC, we're going to get an aldehyde. So this is how it proceeds. But first of all, I want to show you the reaction mechanism and how you're supposed to go about uh, the same reaction mechanism and how we got this product. So this product here is a ketone. What we're having here is a ketone that we're forming. The ketone came from the oxidation of the secondary alcohol by a reagent known as PCC. So now let me just show the reaction mechanism to give you a clear analysis of what I'm doing here. So the structure that we had initially was this. This was our structure. OH, OCH3. In the presence of what? In the presence of PCC. So one thing that we must know about PCC is that it has a structure for itself. Like it belongs to a certain structure. It has a structure. PCC has a structure. And the structure of the PCC is this CR, which is double bonded to two oxygens. So there's a double bond to oxygen here, and there's another double bond to oxygen connected to a chlorine, and then it's also connected to another oxygen, single bonded to another oxygen, and then we have our negative electron there. So one thing that we must understand here is that this part of the center of this structure here is chromium, and this chromium is what? Positively charged. And we're having the oxygen here, which is negatively charged. So we're going to have an attack, and this attack is going to come from the oxygen attacking the center of the what? Of the chromium. And when that attack happens there, we're going to break down one double bond which is connected to the oxygen. So the double bond will break there. And what structure are we going to have? We're going to have this. So we're still going to maintain our structure there. We're having that. And then we have the oxygen here, which is bonded to the hydrogen. The hydrogen that is present there is there. And then we have a lone pair of electrons, or the two electrons that are attached at the center of the chromium here. And then we have that bond now forming. The bond that we just formed is this one here, which has connected to the CR, which is now double bonded to one oxygen. The CR is also bonded, single bonded to the other oxygen. There we go. And then it is also single bonded to the other oxygen here, because we know this was a double bond, but it has broken down to only one oxygen. So this is 1, 2, 3, 4, 5, 6, and then this becomes negatively charged, and then you have your chlorine there. And then we just have to finish up the rest of the structure, which was this OCH3. So that's what we're having right now. So what's the next step? I want us to understand here is that one thing that we must understand here is that we are having the oxygen here, which is negatively charged. Because it is negatively charged, it makes it very reactive. So what we're going to have here is a proton transfer. We're going to have an intramolecular reaction here. Okay, so we're going to have, so I'll just show it down here. We're going to have a proton transfer. Since we have the hydrogen that is here, and we know to say that all this oxygen and that oxygen is very active because it is negative, it is very electronegative, and it's negative there. So we're going to have this oxygen here, or the other oxygen here, attacking the proton that is right here. So we're going to have this attack, and when this attacks the number of electrons that were here will leave this and join the oxygen. Then we go up. So our structure is going to be something like this. So this number of electrons have come here. Our structure still maintains. We're still having the oxygen there, the number of electrons, the two number of electrons there, and we're still having the CR, which is double bonded to the oxygen, which is single bonded to the other oxygen here. 1, 2, 3, 4, 5, 6, negatively charged. The oxygen that was here reacted or got the proton that was here, which is the hydrogen. So we're just going to have HO right there. And then don't forget, we also had the chlorine in the compound. So this is 1, 2, 3, 4. We still have our structure here, which is CH3. Alright, so this is where we are. So now this will continue to proceed. So we are still proceeding on. So now you can look at this structure here, and you will see that it will undergo now what we are calling resonance. These number of electrons that are on the oxygen here will join back to stabilize. So when these number of electrons join back, they will attack that to form the double bond, and then what will happen is we're going to kick out the chlorine. So our structure now is going to be still maintains. We have the oxygen here, the two lone pair of electrons, then you have the CR here, and then we have the HO, and then we have the double bond to oxygen, and then we know we have formed the double bond here as well, and then the chlorine has been moved out, so this structure still maintains. We're having OCH3, and what else is in the compound? We're having chlorine in the compound. There we go. So what's the next step here? One thing that we must understand is that we in as much as this compound here is joined to the oxygen, we have the number of hydrogens that are here, which is one hydrogen, just right here. We have it. So the chlorine that was pushed out from the first compound will come and attack to get this hydrogen that is there. And when it gets this hydrogen, what is going to happen is that this number of electrons that are here will join to form a double bond there. And what are we going to have? And when it forms a double bond there, the number of electrons that are here will be kicked out, or this entire structure will be kicked out, so that we can have the formation of a double bond to the oxygen. This goes out. So our final product now becomes this. We have O here, there's a double bond there, then we're having that, having that, having that, having that, and we're having OCH3. Okay, and initially that was our product. We formed a ketone here, and true to the core, this is the reaction mechanism that is going to happen, because you know that PCC is a weak oxidizing agent working on the secondary alcohol to form a ketone. But if the alcohol that we had was a primary alcohol, would have formed an aldehyde. So what we have right now is this product here, which is called what? The ketone. Our main interest was this part here, because what we had here initially was what? What we had initially here was the alcohol. So in the presence of PCC, which is a weak oxidizing agent, they're going to form the ketone. So other structures, if you want to show other structures that have been formed as part of the product, we're having the HCl here, because this hydrogen was taken to join with the chlorine. So we're having HCl, then plus our other structure that is here. So we're having the oxygen double bonded to the Cr, then which is also double bonded to the oxygen there, double bonded to the oxygen right there, and then we have HO. But also that one thing that we must note here is that in the structure of the PCC we have a pyrimidine. Okay, this is but our end product. This is our answer here. This was the structure that we are looking for in the question. This was the structure that we are looking for. Okay, this is our answer. But one thing I just need to point out is that uh, PCC PCC I mentioned to say we're having the first structure, which was the chromium attached to 2 to 3 oxygen atoms, and also attached to the chlorine. But we also have the pyrimidine in the compound. Okay, we have a pyrimidine like this, which is N attached to the oxygen, and then the double bonds will appear like that. So what will happen is that this other product that we formed, which was there, is going to undergo resonance. To undergo resonance, we're going to have, which is bonded to the chromium, and then this number of electrons will come and join there to come and form that 1 2 3 4 5 6. We're going to have that, and then this is double bonded to the oxygen, which is also equal to the HO. So this is negatively charged. It will come and attack here to come and get the hydrogen from the pyrimidine, and the structure we're going to form is this: oxygen to that, we're going to form OH there, and then we're also going to form what? This is double bonded to the oxygen, and this is OH. So I've got now 2 atoms of hydroxide in the compound. So this is the other structure that you're going to form. So the end products in this chemical reaction, we have the first answer that we're looking for here, which is the ketone, the HCl, because we know the hydrogen bonded with the chlorine, and then the other structure that we're having in the compound is this structure right here. Okay, plus also the remains of the pyrimidine, which is the structure. She's there, there, with the two lone pairs of electrons, and then plus this other structure that right there. So this is how it works out. So one of the most important lessons that I want you to pick out from here is that we're having PCC, and PCC is a very weak oxidizing agent. It can only oxidize the alcohol, the primary alcohol, the secondary alcohol to the aldehydes and to the ketones. But when you use a strong oxidizing agent such as the Jones reagent, we are going to have the secondary alcohol proceeding on from the ketone to the formation of the carboxylic acid. But what we have right now is PCC, which is a weak oxidizing agent, oxidizing the secondary alcohol to a ketone. So this is how it works out. In the next video, we're looking at the second question.